Historically, Aristotle is regarded as someone who had some very significant input into modern science. Unfortunately, the evidence is somewhat different to this. Aristotle used logic and argument to support his theories about the world, and most of his theories have proved to be untrue. For example, he had a view that women had fewer teeth than men did. Now, all he had to do was ask a woman to open her mouth, and he simply had to count the number of teeth she had, and then count the number of teeth that a man had, and then go and repeat that count 20, 30, 40 times until he could make some reasoned conclusion on whether women in fact had fewer teeth than men or not. He never did that. Why he came to the conclusion that women had fewer teeth than men, I have no idea. Unfortunately, whilst this incident is laughable, many other things that Aristotle concluded were less so. He argued, for example, that a ball dropped from the top of the mast of a ship would hit the rear of the ship, would not fall directly to the bottom of the mast of the ship, but would actually fall to the rear of the ship, because he reasoned that when the ball was released, the ship would move forward, and therefore the ball would strike the deck at some distance toward the rear of the ship. Clearly he never did this experiment, because if he did, he would have found out that he was totally wrong about this. The problem is that this kind of logic prevailed for over 2,000 years. It became embedded in the Western European Christian Church, and it led to people being imprisoned and people being burned at the stake for holding views different to the one that the church adopted. This was hardly scientific. So a lot of the credit that Aristotle gets for the foundations of modern science are really misplaced indeed. Let's look at a simulation here of one of the things that Aristotle talked about, which was the fact that he believed that if you dropped a weight from the top of the mast of a ship, that weight would at the stern of the boat. Here I've got a cart. This cart is able to move at a certain speed along this track. We can control the speed at which the cart moves, but whatever speed we choose, it will be a constant speed along this little track. Now I'm going to stop the cart, so we're going to have it stationary, and I also have the ability to fire a ball out of that little cylinder that's on the top of the cart. Here we go. We're going to fire a ball out of the top, and I can control the speed that the ball comes out of that cylinder with. We can shoot it with a small speed. We'll go up and come down only a small distance, or we can shoot it with a much larger speed and it will go up much higher. Now, no one will dispute the fact that this ball can be thrown up and from the stationary cart. My question to you is, if I now have this cart move along at a constant speed, and then I throw the ball out of the chimney, will the ball go back into the cylinder, or will it miss? Will it do what Aristotle claimed it will do and hit the ground from the point at which it is thrown? Let's have a look at what happens. Let's allow the cart to move at a reasonable speed. Now, I remind you that the cart is moving in this demonstration with a constant speed, and this is quite important. So the cart is moving along, and then as it is moving along, the ball is fired out of this little cannon that sits on top of the cart. And we can see that the ball returns back into the cannon. Perfect shot every time, perfect basket every time. It returns into the chamber from which it was fired. And this is true if we change velocity at which the ball is thrown from the cart. If we throw it with a smaller velocity, it won't go up nearly as but it will return into the cylinder of the cart. Now, whilst this is just a simulation, it shows very clearly that Aristotle it took Galileo to do the experiment, and there is strong evidence to suggest that he actually did do the experiment of dropping a weight from a moving and that it hit directly below the which was a completely different attitude to our notions of motion that had existed up until the time of Galileo. It is Galileo who is the true father of science, the first person who ever linked observation to hypothesis and further experiment to verify those hypotheses. This is the very foundations of science. Galileo realized that you could not do science by just hypothesizing, just theorizing about the world in which we lived. We had to do the experiments, and without the experimental underpinnings for our theories really didn't have a chance of being proved to be true. I'd just like to do one more thing with this little cart now, and that's the path that this ball follows. You can see that this is a perfect parabola. This is what's known in physics as projectile motion. Why does the ball stay in the same place over the cart as it's fired from the cart? Very simply, it had a velocity when it was thrown. It had a horizontal velocity when it was thrown. And in the absence of air resistance, and we do have to ignore air resistance, but you see examples of this all the time. If you're sitting in an aeroplane, you can throw up something into the air and catch it again, even though the plane is moving at maybe 1,000 kilometers per hour. The article, when you throw it into the air, doesn't fly back and hit you in the face at 1,000 kilometers an hour. Whatever you've got in your hand is moving at the same speed you are, just like the ball in our little cart here is moving at the same speed as the cart. And so when it's thrown into the air, it simply returns into the cylinder. It falls back to the exact same position it had before the cart was moving.